Isn't that cool? I think that's pretty cool. Oh, you don't need to. Okay, cool. So, what you see before you are 3 neon lights and then a filament bulb. So the 3 neon lights are not neon necessarily. This one's neon. And then this one is hydrogen and this one is mercury. So basically these are all gases and they're being electrically charged so that it excites the gases and then they stream through this tube and light up basically. And then this one is just a filament bulb. It's like metal that's being heated by the electricity. So what you're seeing through the glasses right now is a spectrum. This one has the full spectrum because it's a white light. It's not like these, which is a gas. So each gas, you'll see that this one has like a green bar, a blue bar, and then something else. And then this one has also an array of like different colors. And this one does too. So the differences between this one and these is that the gases are basically like they're different than this one because this is metal and it's got electrons.
It's not like a Bailey, so it's okay. So like, this one has like, so the way metal works is it has like a sea of electrons floating around in it, right? So it's able to, when it's excited by the electricity, it's able to emit a lot of different like size packets of light, and so it gives all these different colors. So you have this full spectrum here, whereas these is just one atom, and so it has different energy levels.
Yeah, the electrons are more bound to each nucleus of the atom, so that's why the electrons can't jump around as much. But with this one, all the electrons are jumping around all the time, so they're reflecting all the different wavelengths of light. Whereas these ones, like this one's reflecting only about 3 different wavelengths of light, and you can see that in the glasses. Now this is pretty cool, but it's got basically no practical application in life. But if you go outside and you look at the sun, you'll see a really cool spectrum. It's like this one, but if you look closely, you'll see that there are certain lines that are omitted. They're like black bars inside of them, and that's caused by something called black body radiation. So the black body radiation spectrum has these bars because the sun does emit pure light like this, but there are gases that are around the star that are like, so for example, there's sodium caused by the nuclear fusion in the sun. There's like random heavier atoms around the sun. So for example, sodium is hanging out around the sun, and sodium likes to absorb yellow light in particular. So if you look at the sun, you'll see 2 bars of yellow are gone, and that's caused by the sodium in space. So this is what we use to figure out the composition of stars throughout space, and basically we can see like what planets have, what kind of like chemical makeup a planet or a star has. So yeah.
So there's like no practical application like for everyday use, but it's practical.
Yeah.
Well, this particular
one, like, I mean, you can walk around with these glasses and it's pretty cool and you get to see rainbows. Like, if you look at a normal light, you'll see a spectrum like this, and then, yeah.
The scientific concept behind this, though, has lots of practical applications.
Yeah.
But just having like 4 different bulbs in your house, like that doesn't have much application except looking cool. Yeah.
That's
So yeah, that's what this is all about. It's pretty cool. And you guys can keep those glasses.
And look at stuff.
Yeah.
And also look really cool all the time.